the circadian system is really an anticipatory system in your body that prepares your body to do whatever it would need to do. So it's going to help your digestive system kind of shut down and break down calories that you already have when you're sleeping so you can fuel yourself when it expects you to fast. It's going to predict when it should have a cortisol spike to help you wake up. It's going to predict when your heart rate needs to be lower or your muscle strength needs to be stronger. You are functionally a different person at different times of day from every level, from behavior, molecular structure, like anything that you would get measured at a doctor's office pretty much changes at different times of day, hormone release, anything like that. And we don't, we have to take in cues from our environment. We all have about a 24-hour pattern of how all of these processes work to keep, everything in the right place at the right time. But we coordinate these with the environment. And the two main cues that we get are light and food. So light is going to be the biggest cue to talk to this clock in your brain called the suprachiasmatic nucleus, which is just a geographical term that sounds very complicated. It's just where it's located. But that part of your brain will integrate light signals. It'll help control your sleep-wake patterns, and it kind of talks to all the other clocks throughout your body. And when I say clocks throughout your body, pretty much every cell in your body has a clock. But when you eat, actually directly affects each of those individual clocks directly, because nutrition availability directly signals the cells to say what time of day it is. So if you're eating at the same time every day and you're fasting at the same time every day, your body can predict that. It can have enzymes ready to digest things. It can help coordinate other things that are going on within the cell, because food availability is a very strong cue to tell the cell what time of day it is. Whereas if you're eating at inoptimal times, when your body wouldn't expect it, say the middle of the night, one, your insulin secretion is shut down, so you can't process your glucose properly. Two, you're telling your body it's a different time of day. It may try to shift those clocks directly. There's many different things that can kind of be kind of compromised as how your body would function just by when you're actually eating that food.
So I'm just thinking about this and just throwing this out loud, but let's say it's 11 p.m. at night and it's dark. My central clock is detecting that or being regulated by that change in light from light to darkness, and anticipating that I'm about to go into a state of rest. But then let's say I go and eat a meal. Is it the peripheral clocks that are then becoming disrupted? They're thinking that it's still time to be active and digesting, whilst the central clock is saying, hey, it's time to rest and relax. And so you get kind of a sort of a loss of alignment between those two clocks.
It's a little bit like that. And it's also it's a little bit that, eating is a stimulation cue anyway. It's an arousal cue in its own regard. Like if you're driving late at night and you get tired, the first thing you do is start snacking, and it'll help you wake up. So eating at the wrong time kind of sends a cue to your whole body that it's the wrong time. But like things like when you talk about it's getting dark, well, one of the things that happens at night when it's getting dark is melatonin is secreted. Melatonin directly inhibits insulin secretion. So say you have a milkshake in the middle of the night. Well, now your body can't process that glucose. You might get a really high spike in blood glucose, and those kinds of things that are happening perpetually over and over again can lead to things like prediabetes or diabetes.